If you see this sample, in this portion there is high density signal, that is 20 Hz. Then this low frequency 10 Hz. Then in this portion 5 Hz. Then 2.5. Then again 20, 10, 20, 10, 5, 2.5. If I will connect 1, 0, that is binary address file, to that time 5 Hz signal will reach at output. That is this 5 Hz signal here. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session we are discussing multiplexer or MUX. What is multiplexer? In electrical circuits, in electronics, in digital electronics, it is name of function or behavior of a circuit. When we apply multiple inputs to any component, any item, how many inputs are provided to that component? It will depend on the specifications. 4 inputs, 6 inputs, 2 inputs, more than one input. Sometimes there are 64 lines, sometimes 256 lines, 512 lines, and one output. If it is 4 input, 1 output, it will be called 4 to 1 multiplexer. When we apply inputs to this circuit, this component, and we provide control logic, any code, any command line from any computer, any processor, or manually, maybe it is predefined, it is select input. Based on this select input, this code, it will connect these lines at the output, which is defined in this code. If I will give command to select this input will appear at output. If it is predefined, for how much time this will be connected here, then which input? This one, this one, this one, or maybe this one, again this one. That is predefined in this code based on our requirements. In my last video I discussed 74HC052 IC. It is dual 4 to 1 line multiplexer. One channel, second channel, 4 input, 1 output, 4 input, 1 output. And today we will see it in more details, and we will see behavior of this IC as a multiplexer. It is multiplexer and demultiplexer. 74HC4052 is TTL IC, transistor logic, 5 volt VCC. And if we will discuss CMOS, then CD4052, HEF4052, MC14052, SCL4052. Many numbers are available in this family. It is CMOS 3 volt to 18 volt range, and this is 5 volt range. To explain the behavior of this IC as a multiplexer, I will select one channel. Let's suppose I selected this channel now. We have 4 inputs, Y0, Y1, Y2, Y3. Z output. I connected 1K resistor with one LED and it is grounded. This is 1K resistor. I connected 16 number pin to VCC 5 volt. Pin number 8 ground. Y0, it is pin number 1. Y1, it is pin number 5. Y2 pin number 2, Y3 pin number 4, inputs, outputs. Then there is control logic. 3 pins are used to control this IC, and there is VEE, that is signal ground for this section, that is pin number 7. When we will connect any signal here, signal high side connected here and low side will be connected here, so that this signal will pass through this IC. Pin number 6, that is enable pin. When it is connected to 0, that time this IC will function. Pin number 9, it is S1, pin number 10, S0. These are 2 binary inputs, S1, S0, LSB, MSB, and this is enable pin. Enable is working as a chip select. Here I connected 20 Hz signal. Here I connected 10 Hz signal, 5 Hz, 2.5 Hz. To understand the multiplexer, that how multiplexing is done by this IC. If both pins are connected to 0, 0, ground side, low level, that is address for this pin. At that time 20 Hz signal will come at output. If I will connect 0, 1, that is binary 1, that time this Y1 will reach here, 10 Hz signal will reach at output. If I will select 1, 0, 5 volt here, 0 volt here, that is binary address for 2. 2 decimal, this input will reach at output. 5 Hz signal will reach here. And if I will connect 1, 1, that is binary address for decimal 3, this decimal location pin Y3 input will reach at output. So by controlling these signals, we will select different frequencies in the output. I will provide automatic signal to select these inputs one by one at specified intervals. That time we will receive 20 Hz, then 10 Hz, then 5 Hz, then 2.5 Hz at specified periods. Let's suppose if we have a predefined time intervals to select this signal, let's suppose I need this signal for 1 second. This signal will be connected at output for 1 second, then 5 second time for this pin. This signal will reach for 5 seconds here, then this signal for 10 seconds we will receive here, this signal for just only 2 seconds. So these codes on these 2 pins will change with that time which we defined in the program, which we ordered to the microprocessor, microcontroller, whatsoever. That time, that coded signal, these voltage, step by step, one by one, will ride on this single line. We injected 4 signals, but we converted that signals based on these inputs at one line. Sometime it is this, sometime it is this, sometime it is this. Let's start. To create these signals, I used CD4024 IC here. So I am providing 4 inputs here. Pin number 1, 20 Hz. Then pin number 5. Pin number 5, 10 Hz. Then pin number 2, 5 Hz. Then pin number 4, 2.5 Hz. So I have 4 different signals, 10, 20, 5 and 2.5. And now I have these control signals. I connected pin number 6, 7, 8 to low side that are VEE enable signals, because I am using single supply to power up these modules. Here I am using PWM generator module. I provided 40 Hz signal to this IC to create 20 Hz, 10 Hz, because that is frequency divider 4024. So I created 4 signals by this one module from 40 Hz signals. We can use any signal, any voltage value, and this module I am using to create automated these two control inputs, pin 9 and pin 10. I will connect oscilloscope at pin number 3, that is output pin. We have these two input pins, S0 that is pin number 10 and this is S1. Both inputs connected to low side. We have low inputs. This signal is now 20 Hz here. Now 0, 1. 0 volt and 5 volt. This is pin number 10. 10 Hz frequency is in output. This pin. If I will connect 1, 0, that is binary address for 2, that time 5 Hz signal will reach at output. That is this 5 Hz signal here. And if we will connect binary address for decimal 3, this one 1 1, 2.5 Hz signal is there. The same 4024 IC I connected here to create automated select inputs. If you see this sample, in this portion there is high density signal, that is 20 Hz, then this low frequency 10 Hz, then in this portion 5 Hz, then 2.5, then again 20, 10, 20, 10, 5, 2.5. We are selecting these inputs at specified intervals. If I will increase the frequency of this signal, now we have this pattern. In this pattern we have 4 type of signals, 4 different signals at specified intervals. That are these signals. So this is the function of this multiplexer. If you think this video is informative, you can like this video. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.